quotient rule if the expression is such that it cannot be easily multiplied or divided into separate terms. The product or quotient rule are used. Let's look at some differentiation of a quotient, or probably if you're given a quotient, how do we go by it? Considering this scenario, if y is equal to u v, where u and v are both functions, bring this down a bit, both functions of x, then by the quotient rule, the y, the x is going to be equal to v du dx minus u dv. Let me clean this. U dv dx all over v square. Okay, so according to the quotient rule, if you are given a function y is equal to u over v, where this u is the function, then over it, the v is also a function, and both u and v are functions of x, then we can find the first derivative, or we can differentiate the y with respect to x by following what we have done here. That is, you multiply v by the derivative of u with respect to x minus u by the derivative of what? V with respect to x. Then you divide everything by v squared. Let us take an example to demonstrate how probably such questions are going to be tackled. Example. So probably an example will be enough, right? So this example, given that y is equal to 3x plus 2 all over x minus 6. Differential differentiate with respect to x, or it could be find dy dx, right? Or we can also say find the first derivative of the function. Right, so to differentiate a function y is equal to 3x plus 2 all over x minus 6 with respect to x, we need to first do a declaration of u and our v. And as we said earlier on, the y, the function, to use the quotient rule, then it should be in a form of u over what? V, right? So in doing the declaration, the only thing we're going to do is to compare the position of the u to the given function, right? So if we assume u over v, it's not even an assumption. U over v is a fraction, right? And u is at the what position? If this is a fraction, then the u is at the position of the numerator. So comparing this to our function, the numerator, what is at the numerator? We have 3x plus 2. So you're going to declare that your u is equal to what? 3x plus 2. So we're just basically doing comparison of our function to the generalized function, right? And then your v is also going to be x minus 6, because when you do the comparison, their positions are what? Denominators. Please, you get it? See, v is a denominator, x minus 6 is also what? A denominator. So in doing the declaration, you say u is equal to 3x plus 2, and v is equal to what? X minus 6. Right, so let us continue from this side. We have we going to do, let u be equal to 3x plus 2 and v be equal to x minus 6. Right after this declaration, what we're going to do next is to find the derivative of what? U and v with respect to x. So the du dx is going to give us what? So we're going to differentiate these term by terms, and 3s, if I differentiate it, I'm going to get 3. The 2 is going to be 0, so I didn't write anything because 0 is insignificant. Then I come to the dv dx, right? dv dx, let me try to write it well a bit. So dx, right? So for the dv dx, we're going to have 1, because when we differentiate x, we get 1. Then the minus 6 is a constant. When we differentiate it, we get 0. So actually, differentiating the v, we're going to get 1, right? Now let us recall the quotient rule says that the y dx should be v du dx minus u dv dx all over what? V square. Alright, so actually what we're going to do is just to do some sort of substitution over here by substituting the v in place of whatever we see v. So v is equal to x minus 6, right? So wherever we see v, we write x minus 6. We have found the du dx, which is 3. The dv dx is what? 1. And our u is 3x plus what? 2. Right. So basically my dy dx is going to be the v is what? X minus 6. Right? X minus 6 times the u dx. But the u dx is going to be 3. That's it. We have 3. The minus u. U is what? 3s plus 2, right? 3s plus 2 times what? The v dx, which is 1. Then all over our v squared, and v is x minus what? 6 square. Then we can simplify or multiply these 3 through what is inside this bracket as well as the 1. Okay, and maybe if it is possible, we can do some simplification. So dy dx is going to be equal to 3 times x is going to give us what? 3x, and 3 times minus 6 is going to give us minus what? 18. We have minus 1 times, you know, what is inside the bracket is just going to be the same thing, right? So 3x minus what? 2. Okay, then all over x minus 6 squared. We can simplify our numerator. So we have dy dx is going to be, 3x, that is, let's say, grouping of like this, 3x, and then we have minus 3, so you bring this 3x here, then we have minus what, 18, then minus what, 2, okay, all over x minus 6 squared, okay, then what we're going to do is to simplify it finally. So 3x minus 3x is going to give us 0, and then minus 18 minus 2 will give us minus 1, 20 all over x minus 6 squared. Yeah, so simply that is that. Just quote your quotient true. First you do the declaration of your u and v, right? Then you find the derivative of that, you quote the quotient true, and you do your substitution, right? And that is that. We're done finding the derivative of our function y. Thank you for watching this video. Subscribe to the channel if you find it interesting.